problem number 20. So it says a boy travels 5 kilometers eastwards eastwards, 4 kilometers northwards, and then 2 kilometers westwards. He takes 2 hours for his journey. The magnitude of average velocity of the boy is how much? Of the boy is how much? A boy traveling 5 kilometers east, so it has started from moving east 5 kilometers. Let's say this is 5 kilometers, then 2 kilometers, 4 kilometers north, 4 kilometers north, and 2 kilometers west, 2 kilometers west. So it has started from, let's say, A, moving this way, then B, then C, then say, let's say D, the final position. He takes 2 hours for the journey. The magnitude of the average velocity. So to calculate the average velocity, you need to find this AD. You need to get AD. So now if I drop a perpendicular here, if it is 2 kilometers, let's say this is A. So your AE is equal to AB minus EB, and AB, that is equal to EB means CD or DC or whatever you say. So AB is how much? 5, and DC is this one minus 2. So AE is 3. AE is 3. This one from this to this. Now what is this? How much it will be this? Now again DE equal to CB, that is equal to 4. So you know this and this is 90 degree as it is perpendicular to horizontal line. So your AD is equal to under root AE square plus DE square. So AE is how much I've calculated? 3 square. This is 4 square. So that is 3 square plus 4 square is equal to 9 plus 16, 25. 25 square root is equal to 5. Sorry, AD is 5. So now you have got the value of AD. So if AD is there, average velocity is equal to the AD divided by the total time. It is, if it is for this travel, it is total time t. So that same time has to be considered for this displacement, because that is the result of this position, final this initial position and final position, and the shortest distance is AD, and the time is taken 2 hours. So it is 2 hours. Now see, this is in kilometer and this is an hour. So velocity, if I put it 4, this is 5 by 2 kilometer per hour, so that is equal to 2.5 kilometer per hour will be the result average velocity. Moving to 21. A body travels towards north with a velocity with a velocity 2 meter per second, 2 meter per second for 20 seconds, for 20 seconds, and then moves towards east with velocity 3 meter per second for 10 seconds. Find average velocity. So that means a body traveling towards north with a velocity of 2 meter per second and for 20 seconds. So for 20 seconds, it is reaching some point. Let's say we're starting from A, reaching at B, and then moves towards east with 3 meter per second for 10 seconds. What is this? Average velocity. So if it is initial position, after reaching at B, it has turned to east, from going from north direction to east, is reached at point, let's say A, B, C. So now to get the average velocity, I have to get the shortest distance AC. So the direct displacement is not given. Let's say when it is moving to north, the distance moved by velocity multiplied by the time. So velocity is 2 meter per second and this for 20. So that will give you 40 meter, and that of x east is equal to v into t, same 3 into 10 seconds, 3 into 10, that will give you 30 meter. So now this is 40, AB, xn is equal to AB and xc is equal to BC. So what is your AC then? The shortest distance AC. Shortest distance AC means this is displacement, you can say, equal to under root of AB square plus BC square. So AB is equal to xn square plus xe square. So that is equal to under root of 40 square plus 30 square. Now 30 square 40 square is equal to 2500 square. Now if you square root it, I will get 50 as result, so 50 meter. So this is 50 meter. Now once you will get AC, the time is how much? The time will be the total time during this movement. So this has 2 meter per second for 20 seconds. The time is, total time is, the first movement when it is moved from A to B, now north direction 20, and then now I will write it like that. So to understand Tn and Te when it is moved towards east, so Tn means when the time taken from A to B in the north direction, it is 20, and time taken to move B to C in the east direction, that is equal to 10. So time is equal to 30 and your distance is equal to 50. Then average velocity is equal to the displacement upon total time. So that means 5 by 3 meter per second. This will be your answer. Moving to the sum 22. A vehicle is moving along a straight track with a uniform velocity of 20 meter per second due east. After 5 seconds, it starts retracting. Its path with the uniform velocity v. If its average velocity v average after 15 seconds is 0, then find v. So a vehicle is moving along a straight line track with the uniform velocity 20 meter per second due east A to B. Let's say after 5 seconds it starts retracting. Let's say it has moved A to B by in 5 seconds, then after retracting is moving backward direction with the uniform velocity v. It has a average velocity on the velocity after 15 seconds, so is 0. So average velocity is taken, so it has moved 5 seconds this way, 5 seconds, then after on the backward direction with the v it has moved 10 seconds, so total time is 15. So v average will be the total distance moved. The total distance will be the distance this way, 20 meter per second into 5, plus it will be minus because the displacement is on the other side. So what would be that? V into 10, the remaining second, and the total time is 15. So that V average for 15 seconds it has said to be 0. So then it has to be 0 if the numerator is equal to 0. That means V into 10 equal to 100. That means this is equal to 0. Let me write this step 2. Let me clarity more. So 20 into 5 minus v into 10 is equal to 0. So that means v into 10 equal to this side is equal to 100. So v is equal to your 10. So 10 is unit because this is given in second, this is given in meter per second, so it will be also meter per second. So this will be your answer. Okay, so moving to the next problem, and probably the last problem for this chapter. Then after I will move to different kind of problem, will be on this or on the acceleration itself. So the problem is a body moves with a speed of 10 meter per second due east. After 10 minutes, it moves with a speed of 5 meter per second due west. The change in the velocity of the body during this time interval. So what you say, the body is moving with the speed of 10 meter per second eastwise, so moving with 10 meter per second. Okay, after 10 minutes it moves with a speed of 5 meter due north. So it is not, this is to be understood better way. It has started moving in the east direction with a 10 meter per second after going 10 minutes. So it is moved with a speed of 10 meter per second constant speed, but it's moved 10 minutes. Then after 10 minutes it has changed its velocity towards west with 5 meter per second. So I can take it as a minus 5 meter per second westwise, but it is not said that it has come to a standstill, then after it is just started changing. So there is the trick you have to understood. It has not said it has come to a rest, then after it is on the reverse direction moving the velocity. So then it is said to be what is the velocity, what is the change in the velocity. So the 10 minutes or whatever be the minute, it will not affect the velocity of that motion, because until it is to be retarded or changing its direction, till it is moving in the same direction, it is said to be the v1 is always 10 meter per second. Now suddenly a velocity somehow it has got on the opposite direction, that means it is not the 10 meter being returned to, so it is started moving on the this direction. As 10 meter on the east direction, this is a vector is higher than the 5 meter in this direction. So with the velocity when it is there in the body 10 meter, and the same time it has started moving, how it is possible? Only possible that it has reduced from 10 meter to 5 meter in the same direction. Then only you can say that it has moved. When this can be read in other form, that 10 meters moving in the east direction and 5 meter is, so the ultimate velocity it will there in the body, because this is the same body, and the two velocities cannot be there in the same body at a time. So the representation is such that if it is reduced 5 meter, that means that reduction can be read as 5 meter on the opposite direction, because any negative sign it will signifies the direction is opposite. So that can be read as 10 meter in each direction, and a 5 meter in each direction will give you the same result. So ultimately it will move in the same direction eastwise, but with the reduction speed of 10 meter minus 5 meter, that is with the 5 meters. So there is no calculation as such, but the logic says that it would move with the 5 meter per second and in the direction of east. Okay, so this will be your answer. So this is for now. In the next chapter, that will be chapter number 17, I will move from the problem number 24.